Alright, I'm going to go through the test review. This is going to be very long. Don't watch all of it, just skip around to the parts that you need. I'm also going to show you how to use your calculator to get the most out of it and to be the most efficient with your time. Any notes that I give you or any tips that I give you, I'm going to write in this pink pen just so that you're aware. So our first problem, which is the graph of f of x equals negative x squared plus 4x minus 2. There are a few things that you should be able to pick out right, like very, very quickly, and that is because we all know what a negative number in front of here does. That flips it upside down. So it's already not going to be A, and it's already not going to be B. After that, honestly, I would stick this in your calculator and just match the picture. So we hit our y equals button, and we're going to type this exactly as we see it. Negative x squared plus 4x minus 2. In case you don't have a good window yet, you can hit zoom and then the number 6 to go down here to standard. That gives you your 10 by 10 box. Looks like the picture matches option D. So this is going to be option D. Next, problem 2. Graph the following quadratic equations. Identify the domain, range, axis of symmetry, vertex, and decide if it has a minimum or a maximum. I'm going to fold this over so that you can see it a little bit better. Okay, how we're going to graph these. There's a million different ways to graph this. It's going to keep making that chirpy sound every time I refocus it. There's a million ways to graph this. I think the easiest way is to put this in your calculator and look at the table. So I'm going to put this function into my calculator. Negative 2x squared minus 8x, and make sure that you're using this button for x, not the alpha, plus 2. So I can look at the graph and see what that's going to look like, but that really doesn't help me a ton. If I hit second graph, that will now give me a table. This is way far over, so I want to find some numbers that are actually in my graph. My graph is negative 10 to positive 10, so I needed y values that were negative 10 to positive 10. That is happening here. So now I'm going to graph those points. I have negative 5, negative 8, negative 4, 2, goes up really quick, negative 3, 8, negative 2, 10, negative 1, 8, right, so see it's coming back down now. Let's see, 0, 2, and 1, negative 8. That's as far as I can go. So now I have this lovely little parabola that's going to continue forever. We just don't have room. So now we have the parabola written down. Now we're going to identify the domain, range, axis of symmetry, vertex, and decide if it has a max or a min. Domain. The domain is the same for every quadratic. That says all. That's really bad handwriting. Same for all. Domain is the same for every quadratic, and that is negative infinity to positive infinity. This just means that you could plug in any x value and square it. Next we have the range. This is not the same for every quadratic, but it is always going to be bottom to top. The range is always from the bottom to the top. If we look at the bottom, it keeps going. So the bottom we're going to state as negative infinity. It's a parentheses because we can't actually get to negative infinity. As we move up to the top, we do hit a top point, and not just because our graph runs out, but because this is our highest point. So we go up to a y value, range is all the y values, of 10. We do have a point where y is 10, so that gets a bracket. So that's domain and range. Next is axis of symmetry. Axis of symmetry is this vertical line that goes down our parabola and keeps it all symmetric. And this axis of symmetry is always a vertical line, which means it's x equals. And this vertical line happens when x is -2, so x equals -2. Next we have our vertex. Our vertex we can see is the top point, so it's -2, 10. I do want to also show you the vertex on your table. If you can see it, I'm going to need to refocus, and my hand's going to shake, but that's okay. If we look at the y values, we have -8, 2, 8, 10, 8, 2, -8. Everything has a mirror image. 2 goes to 2 again, -8 goes to -8 again. Everything has a mirror image except for the 10. This is our vertex. -2, 10 is our vertex. So you can always tell what the vertex is because it's the y value without a pair. And then finally we have to decide if this parabola has a maximum or a minimum. This parabola has a maximum. It has a highest point. A minimum would be a lowest point. We've already established that it keeps going down forever. So it has a maximum value at 10. If you'll also notice, our axis of symmetry is x equals -2. That is also the x-coordinate of our vertex. Our maximum is 10. That is also the y-coordinate of our vertex. That will always be the case. Right, next, problem B. This is written in vertex form already, so we can pull the vertex out of this if we want to. It is the opposite of 5, -2. So we have -5, -2. That is vertex form. So we can graph our vertex -5, -2. This has a stretch of 1/2. I'm just going to go ahead and put this in my calculator, also because you're taking a test tomorrow. So we have 1/2. Depending on your calculator, you may need to type 1 divided by 2. It really depends. I have one that you can do a little fraction, but 1 divided by 2 will work just fine. And then parentheses, x plus 5 squared minus 2. You can look at the graph if you want to. The table is what's going to really help you graph this, however. So we already have our vertex of -5, -2. And then this is a fraction. I'm going to skip that. You might have decimals on yours. I'm going to go ahead and skip that. And I'm going to go to -3, 0. So I'm going to graph the point -3, 0. And then my next one's a fraction. If you have a decimal, I'm going to skip that. -1, 6. -1, 6. And it looks like that's probably enough. 16, I can't go that high. So now I'm going to go the other way. So I had my vertex, -5, -2, -7, 0. Graph the point -7, 0. And then -9, 6. So -9, 6. Here's my parabola. It's going to keep going forever. Domain and range. Remember that the domain is the same for every quadratic. Domain is always going to be -infinity to +infinity. The range are all of my y values, just in case you forget that range is y values, domain are x values. We go from the bottom to the top. Our bottom y value is -2, and then we go up forever. So we're starting at -2 and we're going up forever, so infinity. We can't actually reach infinity, so we have a parentheses there, but we do have a point at -2, so it gets a bracket. Axis of symmetry, again, is that vertical line, and because it's a vertical line, it's going to be an x equals. And this is where x equals -5. Again, we see this point with the vertex as well. Our vertex is -5, -2. And as you saw before, the -2, x equals -2. Here we have -5, x equals -5. And our y-coordinate of the vertex will be our minimum or maximum. As we can see here, we do have a minimum, a lowest value. So our minimum is -2. All right, number 3, what is the average rate of change of the function in the table over the interval 2 to 8? I'm going to refocus this again. All right. Average rate of change is a fancy term for slope. We didn't use it before this year because all of our lines just had slopes. Now we have parabolas that don't have a consistent slope, so we use average rate of change for that. Sometimes the slope is higher than other times, so we have to say average rate of change as we average it out. Specifically, we have our slope formula, which is y2 minus y1 over x2 minus x1. This is in pink, so this is just an extra help. This is over the interval 2, 8. These numbers are x values. So they tell us where on our table we're looking for the x values. I have the x value of 2 and the x value of 8, which means my points are 2, -1, and 8, 23. So then I have y2 minus y1, in case you don't remember. Here we have x1, y1, x2, y2. y2 is 23 minus y1, so 23 minus -1, over x2, 8 minus 2. 23 minus -1 is just 23 plus 1, so this is 24. 8 minus 2 is 6, and 24 divided by 6 is 4. So 4 is our average rate of change of this function over the interval 2 to 8. Problem number 4 is also an average rate of change problem. But here they give us an equation instead of giving us a table. Now in theory, what we can do is we can take these x values that they give us, and we can plug in each x value for x. In actuality, it would save us time if we don't do that. If we put this in our calculator and we look at the table, then it'll generate a table just like this one. So y equals -5x squared plus 7x, second table. Here is a table. We want to specifically go from x values -1 to 3, so I'm going to look at the x value -1, Oh, you can't see that. -1 gives me -12. So I have the point -1, -12. And then I also need 3. So I'm going to my x value of 3. It looks like that one is -24. So again, we have x1, y1, x2, y2. y2 minus y1, so -24 minus -12 over x2 minus x1, 3 minus -1. This is plus 12, so -12. This is plus 1, so 4. And our average rate of change is -3. All right, next page. Projectile. So we are going to fully read the problem, as you always should when it's a word problem. Then we're going to pick out the important parts and pick out any parts that we maybe don't care about. A soccer ball is kicked at a velocity of 20 feet per second straight upwards from a height of 2 feet. The height of the ball after t seconds is given by the function h of t equals -16t squared plus 40t plus 2. Find and interpret the vertex of the parabola. Round to the nearest hundredth if necessary. So really the question, it tells us about a soccer ball, and then the question is asking about the vertex. Specifically, we need to find and interpret. The interpreting part is when we care about the fact that it's a soccer ball. Finding the vertex is what we're going to do first. By hand, finding the vertex means first we look for the x-coordinate of our vertex, which is x equals -b over 2a. Now, if you don't remember, our standard form of a quadratic is ax squared plus bx plus c. So b is the coefficient next to x. It does not include the x itself, just the number. A is the coefficient of x squared, doesn't include the x squared, it's just the number, and c is our constant. So in this case, -b, or the opposite of 40, is -40 over 2 times a, looks like a is -16. Order of operations means we need to do the bottom first. -40 over -32. I'm going to just put this in my calculator, -40 divided by -32, and I get 1.25. That means the vertex is 1.25 something. By hand, what you would do is you would plug in 1.25 for t. So I'm going to do this on a separate piece of paper. So h of 1.25, -16, 1.25 squared, plus 40 times 1.25 plus 2. I could put this in my calculator and find it. The other thing I can do is I can put this function in my calculator and calculate the maximum. So I have -16 x squared plus 40 x plus 2. When I go to graph this, it gets way higher than my graph actually is. I'm going to zoom fit, that's option 0, and we'll see if we can see more of this. Now I want to calculate the maximum. So second, calculate maximum. It is a maximum, not a minimum. I want something on the left, enter. Something on the right, enter. The guess doesn't matter, so we hit enter again. And we get 1.249 repeating because my calculator's a little bit screwed up. It's 1.25, and then our maximum is 27. So our vertex is 1.25, 27. Now we have found the vertex. The next thing we're supposed to do is interpret the vertex. So our x value, or in this case our t value, it says after t seconds. So after 1.25 seconds, and then 27, our h of t value, it says the height of the ball after t seconds is given by the function. So h of t is talking about the height. We know that the vertex is the maximum. So after 1.25 seconds, the soccer ball reaches a max height. Sorry for my terrible handwriting, it's been a very long day. Of 27 feet. That is the interpretation of the vertex. Number 6, revenue. A company determines that the revenue from a new product can be modeled by the function r of x equals negative 15x squared plus 210x, where x is the price per unit and r of x is measured in thousands of dollars. And then we have at what price will the product bring in the maximum revenue. So again, we want the maximum. Okay. The maximum in this case is going to be our vertex. And specifically, this says at what price? They told us that x is the price per unit. So we want the x coordinate of the vertex. Well, our x coordinate of the vertex is negative b over 2a. Our b value is 210, so negative 210 over 2 times negative 15. Negative 210 over negative 30, which is positive 7. So at what price will the product bring in the maximum revenue? When it's $7. Sorry, I did not see that the dollar sign was already there. This is just really not very clear. What is the maximum revenue? Revenue is our Rx, so that's our y coordinate of the vertex. So this is what happens when you plug in 7. And honestly, this one's pretty small, so I'm just going to go ahead and plug in 7. I have negative 15 times 7 squared plus 210 times 7. Second quit. Negative 15 times 7 squared plus 210 times 7, and I get 735. What is wrong with me? 735 where this is measured in thousands of dollars. So what is the maximum revenue? $735,000. Number 7, solve the following equations by graphing. When we are talking about solving something, that means that we are looking for the solutions, which also are the x-intercepts, which are also sometimes called the zeros, which are also called the roots. There's lots of names for the solutions of a function. So we want to solve this by graphing, which means we want to graph it and find the solutions, which are our x-intercepts. Now, if you're given a blank graph like this on the test, that means we want you to actually draw the graph. So I'm going to put this in my calculator. Negative x squared plus 3x plus 10. I'm going to look for the graph. That was still my wrong window, so zoom 6 will get it back to normal. So it looks like it's going to go a little bit above the graph that I have. That's okay, because what I'm really looking for are the x-intercepts. There's a couple ways to find this. This first one, I'm going to do my table, and I'm just going to look literally by eye and graph the function. So I have -3, -8, which is down here. -2, 0. Hey, look, an x-intercept. -1, 6. 0, 10. And then it goes up to 12 for a little bit, and then back down to 10, 3, 10, 4, 6, 5, 0. Hey, look, another x-intercept, 5, 0, 6, -8. So here is my parabola. Not very pretty, but that's okay. My x-intercepts are my solutions. I can tell from the table because my y value is 0. So 5, 0. So I have 5, 0. And then I also had -2, 0. So when it says to solve the following equations, I want to find the x. I want x equals, so x equals 5, x equals -2. These are my answers. All right. The other way to find this is to use the calculate function on your graphing calculator. If you see this little blue word calc, second trace will let you calculate. You know how I said that there's a bunch of names for this? We want the 0. Which 0 do I want to calculate? I think I'll calculate this one. So when it says left bound, I need something on the left of this x-intercept. So here's my cursors at the left, enter. I'm going to use the side-to-side arrows. Now I need something on the right, enter. The guess doesn't matter. -2, 0. So just like the -2 that I already had. I can do it again, second calc, 0. And now I want to be on the left of my other x-intercept. So left, right, the guess doesn't matter. 5, 0, right here. All right, next problem, x squared plus 6x plus 9 equals 0. X squared plus 6x plus 9 equals 0, so we want the x-intercept. I can use my table to graph it. Looks like I have the point -3, 0. Hey, look at x-intercept. -2, 1. -1, 4. And 0, 9. And then if I go up, that's going to mirror on the other side. So -3, 0, -4, 1. It won't always mirror, but it won't always mirror with the 0. It happens to this time. -5, 4. And -6, 9. So here's my pretty little parabola. And the only x-intercept I had was the vertex. It is still an x-intercept. It does still hit the x-axis. So that point is -3, 0, which means x equals -3. Letter C. 2x squared plus 4x plus 4. 2x squared plus 4x plus 4. When you look at the graph, you notice that it never has an x-intercept. So when I look at my table, I'm just going to look for the vertex. When I go to my y values, 10, 4, 2, 4, 10. Okay, so it looks like 2 is the middle. Negative 1, 2. Negative 1, 2 is my vertex. And then it goes up to 4. And then up to 10. So this is my skinny parabola. That looks like a sharp corner. It's not supposed to be. But as we can see, it never hits the x-axis, which means that there are no real solutions. Does it mean that there are no solutions at all? No. It means that the solutions are complex numbers, which means it's in the form a plus bi. So there's an I in it. So we do have two solutions, but they are complex solutions, which means if we want to solve this, we would need a different method to solve. Lucky for us, we don't have to solve this because our directions stated to solve by graphing specifically. And since we can't solve it by graphing, we don't have to try anything else. Next page. Problem 8. Use the graph below to graph the quadratic and find the solutions of x squared plus 3x minus 7. Identify the pairs of consecutive integers between which the roots are located. So we're not asked to find the exact solutions, we're asked to find the numbers that it's between. So we're going to go back to our graphing calculator, and we now need x squared plus 3x minus 7. If you look at this, and I know it's hard to see, but our x-intercepts happen in between little tick marks. So I'm going to go to my table, that way I can actually graph some of these points. Looks like negative 5, 3 is a point. Negative 4, negative 3. Negative 3, negative 7. Negative 2, negative 9. And then negative 1, negative 9. This doesn't have a center, at least not on our table. 0, negative 7. We do see that it's mirroring 3, negative 3, and then 3. So it does have a mirror image. It just means that the actual vertex is right in between, so it does go a little bit lower. So we're just going to be a little bit lower. And now when we look for our x-intercepts, we see that they're between negative 4 and negative 5. They're also between 1 and 2. So identify the pairs of consecutive integers between which the roots are located. The first one is located between negative 5 and negative 4. The other one is located between 1 and 2. This has been a very long video, and we're not even halfway done. Fun times. All right, simplify the square root of negative 125. This is where we start to get into I. This is the section 3.3 in your textbook if you need help with it. But a big thing to remember here, and actually a note, so I'm going to put it in pink, is I is equal to the square root of negative 1, and also that I squared equals negative 1. These are two things that you really have to know just like the back of your hand. I is equal to square root of -1, and I squared is -1. So when I go to simplify the square root of -125, I can immediately write that as I times the square root of +125. Now that I'm simplifying square roots, I also need to have kind of a table of, not a table, but a list of perfect squares. If you are not great at generating that, we can go back to our calculator and say x squared. Now when I look at my table, the y values are all perfect squares. I'm going to start, not really with 0 because we don't really care, but we have 1 squared is 1, 2 squared is 4, and we have 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169. I don't know any of the other ones after that. But I could look at my table and find them. 125, we need a perfect square that is a factor of 125. You can do this by dividing 125 by perfect squares, like 49. That didn't work. 125 divided by 36. That didn't work. 125 divided by 25. Hey, that one worked. Or you can put 125 divided by x into your calculator. And then when you look at the table, you want a number probably here that is a perfect square. It looks like 25 is the first one we run into. So that means that I'm going to rewrite 125 as 5 times 25, or 25 times 5. I can take the square root of 25. The square root of 25 is 5. So that means I have 5 times I. I couldn't take the square root of 5, so that stays with the square root. 5i root 5. Simplify the square root of -245. Immediately when I see negative, I'm going to change this to I root 245. And then we want to divide 245 by a bunch of numbers, or we can say 245 divided by x and look at the table. I see a bunch of decimals. Let's see, -245 is not a perfect square, neither is 245. 49 is a perfect square. It's on my list. So I'm going to rewrite this as I times the square root of 49 times, this was 49 times 5. I can take the square root of 49. It is 7. So I have 7i root 5. Right, simplify square root of -49 times the square root of -64. Immediately I root 49 times I root 64. 49 and 64 are both perfect squares. They're on my list. Square root of 49 is 7, so this is 7i. Square root of 64 is 8, so this is 8i. Because these are being multiplied, 7 times 8 is 56, and I times I is I squared. Now remember that note, I squared equals -1. So this is really 56 times -1, or in other words, -56. Alright, simplify the square root of -50 times the square root of -32, so immediately I root 50 times I root 32. I'm not going to look through my calculator for all of these. 50 is 25 times 2. 32 is 16 times 2. Square root of 25 is 5, so I have 5i root 2. Square root of 16 is 4, so I have 4i root 2. Now because all of this is being multiplied, I can multiply 5 times 4, and I get 20. I can multiply I times I, and I get I squared. I can multiply square root of 2 times the square root of 2, and I get the square root of 4. 4 is a perfect square. Square root of 4 is just 2. So I have 20 times I squared, which remember is negative 1, times 2. So 20 times negative 1 times 2 is negative 40. These next 4 problems are my favorite, even though people get them wrong all the time, because we are not multiplying a single thing here. When you look at 13 through 16, we do not see a single multiplication sign, and in fact, we see addition, subtraction, and subtraction. So we are only basically combining like terms. So we have negative 5 plus 3 is negative 2. And negative 2i plus negative 1i is negative 3i. Now remember that complex numbers are in the form a plus bi. So we want all of our numbers to be in that form, and I should have put that in pink and not purple. This is a note for us. A plus bi, we want them in that form. So negative 2 minus 3i is perfect. 1 plus negative 9 is negative 8. 4i plus negative 2i is 2i. Here we are subtracting, so you can think of that as like distributing the subtraction, or you can think of just subtracting. So 2 minus 1 is 1. Negative 10 minus 15, negative 10i minus 15i is negative 25i. Be careful with that one. 23 minus negative 5 is 23 plus 5, so we get 28. 7i minus 4i is 3i. Problem 17 is where we multiply. I hate how blurry this is, but I don't think it's going to ever be any better. So problem 17 is where we are finally multiplying. So I'm just going to do each problem in a different color so that we get this all done and it's easier to tell our work apart. 2 plus 3i times 4 plus I. We have to distribute everything. 2 times 4 is 8. 2 times I is 2i. 3i times 4 is 12i. 3i times I is 3i squared. Remember what I squared is? It's negative 1. Here are some like terms. So we have 8 plus 14i plus 3i squared. I squared is negative 1. So we have 8 plus 14i plus 3 times negative 1, which is just negative 3. And that means that we can combine it with the positive 8. So negative 3 plus 8 is 5. And because we want it in the a plus bi form, we have 5 plus 14i. That is our answer for our first problem. Do we see 5 plus 14i? We do. It's letter B. Next, we have 2 minus 3i times 4 plus I. We have to do the same thing, all the distributing. We have 8. 2 times I is 2i. Negative 3i times 4 is negative 12i. And negative 3i times I is negative 3i squared. Like terms, 8 minus 10i minus 3i squared. Remember that this is negative 1. So then this is positive 3 plus 8 is 11. 11 minus 10i. And we see 11 minus 10i right here, letter E. Finally, we have 2 plus 3i times 4 minus I. 2 times 4 is 8. 2 times negative I is negative 2i. 3i times 4 is positive 12i. 3i times negative I is negative 3i squared. Combine like terms, we have 8 plus 10i minus 3i squared. Remember, I squared is negative 1, and negative 3 times negative 1 is just 3. So if this is just 3, then 8 plus 3 is 11. So we have 11 plus 10i. 11 plus 10i is right here, letter D. At the bottom, we are simplifying fractions. And here's what we need to do to simplify the fraction. The fraction cannot have a square root or an I. When that happens, we need to do a process called rationalizing the denominator, which means we need the complex conjugate. That's a lot of words. Basically, it means if we have a plus bi on the bottom, we have to multiply by a minus bi on both sides, because that way we don't mess up our fraction. So a plus bi, a minus bi. That is what we're doing. So here we have I over 4 minus 3i. I need to stop using that pen. Which means we need 4 plus 3i. And we need it on both the top and bottom. Here we have to do all the distributing. When we do all of that, especially because this is a difference of squares, that's why we set it up that way, we're going to have 16 minus 9i squared. Remember how I squared is negative 1? That means that this will be positive 9. So we have 16 plus 9, which is 25. Here we need to distribute the I to the 4 plus 3i. So we have 4i plus 3i squared. Remember how I squared is negative 1. So this is negative 3, and we put the real number first, so negative 3 plus 4i. Here's our fraction. Our next one, number 19, simplify 5 over 7 plus 2i. If we have 5 over 7 plus 2i, then we need to multiply by 7 minus 2i. 7 minus 2i. Remember, this is a difference of squares, so 49 minus 4i squared. This is then going to be plus 4. 49 plus 4 is 53. And then we have to distribute the 5. We have 35 minus 10i. So our final fraction is 35 minus 10i over 53. And see how these fractions now do not have a square root or an I in the denominator. That was the point. Next page. This is going to be such a long video. Hours and hours, guys. What are the solutions of x squared plus 121 equals 0? There are two ways to solve this. I think the easiest one is to get 121 on the other side and then square root both sides. But on number 22 and 23, we also have to factor the same thing. So you might want to solve 20 and 21 by factoring. It is up to you, though. I'm going to go ahead and subtract 121 on each side. So then x squared equals negative 121. When we are solving, whenever we take the square root of something, we need the positive and negative square root. That does not happen when we're simplifying, but it does when we're solving. So now when I take the square root, this means I is going to be out in front. Square root of 121 is 11, but we do need the positive and negative. So this means x will equal positive and negative 11i. Right, next problem. I'm going to do the same thing. Subtract 81. X squared equals negative 81. Sorry. Now when I take the square root of both sides, I need the positive and negative root of negative 81. The square root of 81 is 9. The square root of negative 1 is I, so we have positive and negative 9i. Number 22, what is the factored form of x squared plus 36? Here's the problem. We do not have a middle term. We can't say that it's a difference of squares because it isn't. It's a sum of squares. But we can write it as a difference of squares. If I chose to do x squared minus, I would then need to adjust my 36 to be negative 36. Now this is a difference of squares. Square root of x squared is x. Square root of negative 36 is 6i. So my factored form is x plus 6i, x minus 6i. That's the same thing I'm going to do on number 23. Instead of x squared plus 49, I need x squared minus negative 49. The square root of x squared is x. The square root of negative 49 is 7i. So because it's a difference of squares, my factored form is x plus 7i, x minus 7i. Number 24, electricity. What is the voltage V of an electronic current of an electronic circuit with a current C of 5 minus 2J and an impedance I of 4 plus J? Use the formula V equals C times I. C times I means we will be multiplying. Just a note here, in electrical engineering, they use the letter J instead of the letter I. So that means that J equals the square root of negative 1, and J squared equals negative 1. That happens throughout electronics and electrical engineering. So if you go into electrical engineering or something, like if you're going to be an electrician, you will probably have to figure this out at least sometimes during school. C times I means we are going to multiply our C and our I. So we have 5 minus 2J times 4 plus J. That means we do all the distributing. 5 times 4 is 20. 5 times J is 5J. Negative 2J times 4 is negative 8J. Negative 2J times J is negative 2J squared. I can combine my like terms. 20 minus 3J minus 2J squared. Remember what we said before, J squared equals negative 1. So this is really plus 2. And if this is plus 2, I can combine it with the 20. So then I have 22 minus 3J. So what is the voltage? 22 minus 3J volts. What is the voltage? Same exact type of problem. Same exact thing. We're going to multiply 6 minus J and 4 plus 3J. So we have 6 minus j, 4 plus 3j, and we are multiplying them, so all the distributing. 6 times 4 is 24, 6 times 3j is 18j, negative j times 4 is negative 4j, negative j times 3j is negative 3j squared. Combine my like terms, 24 plus 14j minus 3j squared. Remember that j squared is negative 1, so this is actually positive 3, which means I can combine it with 24. So I have 27 plus 14j volts. We probably should write volts on here. Alright. Here we are arranging the steps needed to solve. I will tell you on the actual test there are not these multiple choice options. I will also tell you that here we are solving by factoring. Just a quick rundown of how to solve by factoring. First, we need to get the equation to equal 0. Then we factor whatever the expression is. Then we split into 2, where each factor equals 0. And then we solve those two equations. So here we have the problem. I'm going to do orange. 10x squared plus 23x minus 5 equals 0. It already equals 0, so step 1 is done for us. Next we have to factor. We need to factor 10x squared plus 23x minus 5. This has an a value of 10, so we are multiplying it with the negative 5. We need to find two numbers that multiplies to negative 50 and adds to 23. Those numbers are 25 and negative 2. Depending on which way you factor, okay, because not just my students are using this video, so I'm going to explain it grouping first. If you factor by grouping, you have 10x squared plus 25x minus 2x minus 5. Here we have 5x, and what's left is 2x plus 5. Here we need 2x plus 5, so we're going to take out a negative 1, 2x plus 5. Because these match, I can put the coefficients together. 5x minus 1 times 2x plus 5. My students did imposter method, also sometimes called slip and slide. What that means, by the way, this equals 0. What that means is once we get the 25 and the negative 2, we write 10x plus 25, 10x minus 2, and we have to divide by 10. We can't divide either one by 10, but we can divide this first one by 5, and this second by 2. So in total, we divided by 10. So here when we divide by 5, we get 2x plus 5. When we divide by 2, we get 5x minus 1. Look at how these are the same. They're in a different order, but it's fine. They're the same two factors, equals 0. We have now factored it. Now we split it into 2, and we solve. If we're dealing with this, our two factors are 2x plus 5 and 5x minus 1. That is here, g. So our first step is g. We did all of this work just to get to g. After this, we split it into 2. So we have 2x plus 5 equals 0. 5x minus 1 equals 0. If we look at that, that is a. So our next step is a. Now we have to solve each of these. So we subtract 5, 2x equals negative 5, add 1, 5x equals 1. Hey, look, that is B. And finally, we get to finish solving. Divide by 2. X equals negative 5 over 2, which is negative 2.5. Divide by 5. X equals 1 over 5, which is 0.2. So we have H. So these are our solutions. That was the multiple choice piece of it, which you won't really have to know how to do. Number 27, factor and solve the quadratic equation. We are so good at factoring and solving. So here we need two numbers that when you multiply them you get negative 27. When you add them you get negative 6. If you don't remember how to find these two numbers, calculator to the rescue. We need two numbers that multiply to negative 27. So I'm putting negative 27 divided by x. And now I'm going to look at the table. And I'm going to go across the table and I'm going to add. Because everything across the table multiplies to negative 27. So negative 3 plus 9 is 6. Okay, I need negative 6. Negative 1 plus 27 is 26. 1 plus negative 27 is negative 26. 3 plus negative 9 is negative 6. So I have 3 and negative 9. That means my factored form is x plus 3, x minus 9 equals 0. And then my solutions are when we set each of these equal to 0. If we do x plus 3 equals 0, we subtract 3. We get x equals negative 3. X minus 9 equals 0, we add 9, we get x equals 9. Number 28, we're going to factor and solve again. I'm going to do it in a different color, just so that we can tell these two problems apart. Multiplying to negative 36, adding to 9. If you don't know, negative 36 divided by x, and then we can look at the table. We want to add up to 9. Negative 4 plus 9 is 5. Negative 3 plus 12 is 9. We found that one so quickly. Negative 3 and 12. That means factored form. X minus 3, x plus 12 equals 0. Our solutions, x equals positive 3 because we would have to add 3. X equals negative 12 because we'd have to subtract 12. All right, use a quadratic equation to find two real numbers with a sum of 12.5 and a product of 36. Now this really depends on how many points you want. If you want all the points, then we have to pay attention to this use a quadratic equation piece. If you are watching this video because you're hopelessly lost, this is going to be a hard thing to do, to use a quadratic equation. In which case, you might want an easier way to just solve the problem. It won't use a quadratic equation, so you won't get all of the points, but you will get most of the points. If we don't want to use a quadratic equation, then we are looking for two numbers with a sum of 12.5 and a product of 36. That's what we were just doing. So multiplying to 36 and adding to 12.5, our calculator can find that for us, and we can find these two numbers. Problem done. Now in order to use a quadratic equation, it is going to be more difficult. And I'm actually going to get out a pen because I don't have quite enough room. So quadratic equation to find two real numbers. Our two numbers are going to be x and y, a and b, it does not matter, with a sum of 12.5. So I'm going to say x plus y equals 12.5. And a product, which means they multiply, of 36. So x times y equals 36. Now, if I solve this first equation for y, I would subtract the x over, so y equals negative x plus 12.5. That allows me to rewrite this equation. So instead of x times y, it's going to be x times negative x plus 12.5, since y equals negative x plus 12.5. Here's my x times y equals 36. I distribute my x. I have negative x squared plus 12.5x equals 36. Okay. Now I can solve this by factoring, not really because of the 12.5, but same way I can do this. I can solve it by factoring. I can solve it by quadratic formula. I could solve it by completing the square. Not gonna. I need to subtract the 36, but I also don't want the x squared. So I'm going to subtract 36 and divide everything by negative 1. So this is going to be positive x squared, negative 12.5x. This was going to be negative 36 when I subtract, but then divided by negative 1, so plus 36 equals 0. Hey, look, I need two numbers that multiply to 36 and add to 12.5, to negative 12.5. Same deal. Okay, so if this is negative, it'll just be negative numbers. Our total answers will end up being the same. And let me tell you what I mean. If I want it to multiply to 36, so 36 divided by x, look at my table. If I'm adding to negative 12.5, but I'm multiplying to a positive 36, both of my numbers are going to be negative. Negative 8 and negative 4.5 do it, which means this is x minus 8, x minus 4.5, which means x equals 8, x equals 4.5. Those are my solutions. If I wanted to just go straight from here and lose the 1 point for not using a quadratic equation, I want it to multiply to 36 and add to positive 12.5. That happens. 8 plus 4.5 is 12.5. So again, I have 8 and 4.5. Either way, my solutions are 8 and 4.5. Use a quadratic equation to find two real numbers with a sum of 39 and a product of 248. This one I have a little bit more room, so I'm going to use a little bit of a thicker pen. A sum of 39, so x plus y equals 39. A product of 248, x times y equals 248. Going to solve this for y, negative x plus 36. So now instead of x times y, I have x times this version of y, negative x plus 36 equals 248. I distribute the x, negative x squared plus 36x equals 248. Subtract the 248, negative x squared plus 36x minus 248 equals 0. Divide by negative 1. X squared minus 36x plus 248 equals 0 divided by negative 1 is still 0. So I'm now looking for two numbers that multiply to 248 and add to negative 36. Those two numbers are negative 8 and negative 31. So that means I have x minus 8, x minus 31 equals 0. If each of these equals 0, then I would need to add 8, x equals 8. I would need to add 31, x equals 31. I made a typo here. The answers are correct because I was looking at my other key, but this should have been a 39 the whole time. so that's fun. Let's just pretend. The 8 and the 31 are correct, though. I just rewrote it wrong all the way back here. Fun. All right, next page. We are at over an hour. Holy cow. It is not going to upload, I think. Rectangular image on a computer monitor is 256 pixels long and 192 pixels wide. As part of the animation, the length and width of the image are each decreased by 8 pixels every second. The total number of pixels in the image after t seconds is given by the function a of t equals 256 minus 8t times 192 minus 8t. After how many seconds will the pixels be reduced to 0? This, we're asking after how many seconds will it equal 0? So we have 256 minus 8t times 192 minus 8t equals 0. We're already halfway done solving by factoring. This is already factored. We just need to split it into 2 and solve. 256 minus 8t equals 0. It's really hard to do without another piece of paper underneath it. 192 minus 8t equals 0. And now we solve. I'm going to add the 8t over here, so 256 equals 8t, divide by 8, and I get 32 equals t. So 32 is one of my answers. Here I'm going to add the 8t over, 192 equals 8t, divide by 8, and I get 24. So my two answers are 32 and 24. But if I'm thinking about what's actually happening with this animation, it's getting smaller and smaller and smaller until the pixels are reduced to 0, until it disappears. That's going to happen at 24. If the animation is truly using this function, what will happen is it will disappear. It'll be technically negative for a few seconds, and then it will reappear after 32 seconds, and it'll get bigger from there because of the parabola having that shape where it's going to go down and come back up. But in real life, that's probably not what the animation is doing. It's probably just decreasing until it gets to 0, so that will happen at 24 seconds. Number 32, what value of c makes x squared minus 28x plus c a perfect square? Then write it as a square. This is what they mean by square of a binomial. We're also going to write it as a perfect square trinomial. So here's what we do. The negative 28 gets cut in half. We get negative 14. So we are looking for b over 2. That is our negative 14. And then we want b over 2 squared. That is negative 14 squared. Please put the parentheses around it. And then when you get that, you get 196. So what value of c makes it a perfect square? The 196. So c equals 196. Write the expression as a perfect square trinomial. That is the trinomial x squared minus 28x plus 196. And then as the square of a binomial. That is where this b over 2 comes in handy. This trinomial factors to x minus 14 squared. So we have c, trinomial, binomial. We're going to do the same thing. Plus 42x plus c. We need our b over 2 is 21. Our b over 2 squared is 21 squared, which is 441. So c equals 441. Our perfect square trinomial, x squared plus 42x plus 441. And then as the square, x plus 21 squared. Write the function in vertex form. what happens when we're writing in vertex form is we want to make a perfect square. This -2 does not help us make a perfect square. So we're going to move it to the side. So we have x squared plus 4x. We want some other value. So we're going to change, -2 is going to be back here. You can't even see that. We're going to do the same thing that we did up here where we want to know what value. So we take b divided by 2 is 2. And then 2 squared is 4. So we need to add 4. But since I just added a 4 that wasn't even there, I now need to subtract 4. So here, this is my perfect square trinomial. I have x plus 2 squared minus 2 minus 4, which is -6. So now my function in vertex form, y equals x plus 2 squared minus 6. If you remember from before, in vertex form, our axis of symmetry is the opposite of this number with x. So axis of symmetry is x equals -2. The vertex is -2 and then -6. Does it have a maximum or a minimum? Well, because this has a +1 in front of it, because it's positive, this parabola goes up, which means the vertex is a minimum, and it's at -6. Now, if you have another math teacher and you're doing this process of completing the square may not have made sense to you. So on 35, I'm going to do the other one on a different piece of paper. Here, I think the other teacher taught it so that we add the 9 over first, so it's y plus 9 equals x squared minus 6x. Now we have x squared minus 6x. We have our blank. And this is where we cut this number in half. We get -3. Square it, we get +9, which means we also need to add 9 to the other side. So then this gives us y plus 18. Here's our perfect square trinomial, x minus 3 squared. Now we're going to subtract the 18 back over. Y equals x minus 3 squared minus 18. My students, we just slid the -9 over. We still cut the -6 in half, we get -3. We square it, we get +9, so we're going to add 9 and subtract 9 on the end. This is our perfect squared trinomial. So we have x minus 3 squared, and then -9 minus 9 is -18. Either way, you see we get to the same answer regardless. So function in vertex form, y equals x minus 3 squared minus 18. Axis of symmetry, x equals the opposite of -3, which is 3. Vertex is 3, -18. Is it a maximum or a minimum? Because this is a positive a value, we're going up, which means our vertex is a minimum, and it's a minimum of -18. All right, use the discriminant. The discriminant. We love the discriminant. To describe the number of solutions of the following equations. So first of all, what is the discriminant? We have our quadratic formula. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Bet you loved hearing me sing that for you. The discriminant is specifically just the b squared minus 4ac. So it's just telling us what we would have underneath a square root. We need it to equal 0 first before we can plug in a, b, and c. This does equal 0. So it looks like a equals -1, b equals 8, c equals -16. Our discriminant is b squared minus 4ac, which in this case is 8 squared minus 4 times negative 1 times negative 16. When you do all of this in your calculator, you get 0. So the discriminant equals 0. What that actually looks like is when you go to do the quadratic formula. Sorry, give me a second. When you go to do the quadratic formula, you have your x is equal to negative b plus or minus the square root of 0 all over 2a. Square root of 0 is just 0. So negative b plus or minus 0 over 2a. Well, regardless of what negative b is, if I add 0, it does nothing. If I subtract 0, it does nothing. So this doesn't even matter, which means we're not going to have a plus and minus, which also means we're only going to have one solution. And that solution will be kind of a nice number. Might be a fraction, but it won't have any square roots in it, it won't have any i's in it. So we say that it's rational. Because it doesn't have any i's, it's also real. So we have one real and rational solution. Okay, next problem. Finding the discriminant. A equals 1, b equals 8, c equals negative 16. We have b squared minus 4ac. 8 squared minus 4 times 1 times negative 16. We now get 128. So if I were doing the quadratic formula, I have x is equal to negative b plus or minus the square root of 128 all over 2a. 128 is not a perfect square. If I try to take the square root of 128, I get something nasty. I can simplify the square root of 128, but ultimately my answer will still have a square root in it, and it will still have a plus or minus in it. What it will not have is I, because the discriminant is still a positive number. If this were negative, it would have an I. But because it has a plus or minus, it has two solutions. Because it's positive and not negative, these are real solutions. But because this is not a perfect square, these are irrational solutions. So two real but irrational solutions. Finally, I have, this one is not even equal to 0 yet. Please make sure that you fix that. We need to subtract 5. 2x squared plus 9x minus 5 equals 0. A is 2. B is 9. C is negative 5. B squared minus 4ac is 9 squared minus 4 times 2 times negative 5, which is 121. So now when I look at my quadratic formula that I want to do, I have x is equal to negative b plus or minus the square root of 121 all over 2a. I can do the square root of 121. It's nice. Square root of 121 is 11. So this is negative b plus or minus 11 over 2a. There is no square root in this. There is no I in this. But there is a plus or minus. So we have two real and rational solutions. So it's real because there's no I. It's rational because there's no square root. There's two of them because we have the plus and the minus. Alright, we are finally at the last page of our test review. It has been almost an hour and a half. This is going to be a terribly long video. Use any method to find the solutions of the following quadratic equations. Any method. Think about why you are choosing a particular method. Some are easier than others in certain situations. Make sure you use at least each method once. Here are our methods. We can solve by graphing. This will only work if our x-intercepts are whole numbers, so it almost never works. That's why we probably don't do it unless it says solve by graphing, or unless there's a plain graph there that you need to graph. You can always try it, but it's not usually going to work. So that's probably not going to happen. Our next option is to solve by factoring. Just to remind you what solving by factoring is, and I'm going to do an example. So let's say that I have x squared plus 4x plus 3 equals 0. First of all, I have to make it equal 0. Needs to equal 0 first. Then I have to factor it. This is x plus 3, x plus 1. Then I need each of them to equal 0. And then I solve. X equals negative 3, x equals negative 1. Okay, solve by factoring. Next, I solve using square roots or completing the square. Okay. Solving using square roots or completing the square. I'm going to do the same example. Right, completing the square, I'm going to move the 3 over. Negative 3, I need that little blank. 4x divided by 2 is 2. 2 squared is 4, so I'm going to add 4 on both sides. That gives me my perfect square of x plus 2 squared equals negative 3 plus 4 equals 1. Now that I have this, I get to take the square root of each side. Square root will cancel out the squared. I also need plus and minus here. The square root of 1 is 1, so I have positive and negative 1. X plus 2 equals positive and negative 1. So I subtract 2, x equals negative 2 plus or minus 1. I've got negative 2 plus 1 is negative 1. Negative 2 minus 1 is negative 3. Hey, look, same answers, obviously. And then our last is to solve by quadratic formula. Which is, we're going to sing it. First of all, you do need it to equal 0 first. So it does need to equal 0, and then in this case, a equals 1, b equals 4, c equals 3. So we have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We plug in the a, b, and c's that we have. Negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 3 all over 2 times 1. This is negative 4 plus or minus, let's see, 16 minus 12 is 4, all over 2. Square root of 4 is 2, negative 4 plus or minus 2 over 2. Negative 4 plus 2 is negative 2 over 2, which is negative 1. Negative 4 minus 2 is negative 6 over 2, which is negative 3. So now that we have all three methods, we're going to look at these problems and determine which one is most appropriate. So problem A, when I look at problem A, this x plus 3, x minus 7, looks like it's already been factored. So I'm just going to finish solving it by factoring. So I have x plus 3 equals 0, x minus 7 equals 0, x equals negative 3, x equals 7. Great. This one doesn't particularly look like any of this. I do see that I have an x squared and not an x term. which means I could take the square root. I will need to divide by 5 first. Right, so then 180 divided by 5 is 36. So I have x squared equals 36. That means that I can square root both sides. I need the plus and minus, positive and negative. Square root of 36 is 6, so x equals positive and negative 6. Great. Letter C, this is a trinomial. It does equal 0. So our options are completing the square, solving by factoring, or using the quadratic formula. I do not want to complete the square. That is a big mess when you have an a value other than 1. So if a is not 1, I'm not even going to touch square roots, which means factoring or quadratic formula. Factoring is quicker if we can factor. If we can't, then we use quadratic formula. So if we can factor, we need something that multiplies to negative 24 and adds to negative 7. If we have any numbers that multiply to negative 24 and add to negative 7, we can factor this, and we don't, which means we're going to have to do the quadratic formula. A equals 4, B equals negative 7, C equals negative 6. X is equal to negative b, so positive 7, plus or minus the square root of b squared, so negative 7 squared, or just 7 squared, minus 4ac, 4 times negative 6, all over 2a, 2 times 4. I'm going to put the whole discriminant in my calculator. So parentheses, negative 7 squared. Make sure you have parentheses or else your calculator will square it wrong. Minus 4 times negative 6, and I get 145. X equals 7 plus or minus the square root of 145 over 8. There actually aren't any perfect square factors of 145, so we keep this. All right, letter D. We have it equal to a number. It's not 0, so it's not currently ready to factor. We would need to get it to equal 0 first. However, we could complete the square, because that doesn't matter if there's another number over here. And actually, in looking at this, x squared plus 8x plus 16, if I do 8 divided by 2, I get 4, and 4 squared is 16. This is already a perfect square. So we can just write it as the perfect square of x plus 4 squared. Which means we're going to do this by square roots. It is now x plus 4 squared equals 9. So we're going to take the square root. We need positive and negative here. Square root cancels the squared, so x plus 4 equals positive and negative 3. We subtract the 4, so x equals negative 4 plus and minus 3. Negative 4 plus 3 is negative 1. Negative 4 minus 3 is negative 7. Letter E. This is already something squared, so we're going to do square roots here, even though 40 is not a perfect square. We do need plus and minus. And we can simplify the square root of 40. 40 is 4 times 10, so the square root of that, 2 root 10. So we have x minus 1 equals positive or negative 2 root 10. We're going to add the 1, x equals 1 plus or minus 2 root 10. We don't want the decimal approximation for any of these. Only time we want that is in a word problem where they're telling us to round. F. This looks like it's already been factored right here. So we're just going to finish solving it by factoring. 3x plus 5 equals 0. X minus 1 equals 0. So x equals 1. Here we would subtract the 5, so negative 5 divided by 3. X equals negative 5 over 3. G. This looks like square roots. We have a number in front of it, but it is something squared. So we're going to divide off the 2. We have x plus 7 squared equals 9. We're going to take the square root of both sides, which means positive and negative. X plus 7 equals positive and negative 3. Subtract the 7. X equals negative 7 plus or minus 3, where we can now do negative 7 plus 3 is negative 4. Negative 7 minus 3 is negative 10. I've not really been writing these answers very nicely. X equals negative 4, x equals negative 10. That's how we're supposed to write them. It's just very late. It's 6:20 in the evening. Alright, next one, this does equal 9. So we can think about completing the square here. It looks like this isn't a perfect square yet. Not a big deal. Negative 4 divided by 2 is negative 2. We square it, we get 4. So we want x squared minus 4x plus 4. That means that we do need to add the 12 over here. So equals 9 plus 12, also plus 4. Because we needed to add the 4 to complete our square. So we have x minus 2 squared. And then 9 plus 12 plus 4 is 25. We're going to take the square root of both sides. So x minus 2 equals positive and negative 5. Sorry, I forgot to write that. You add the 2 over. X equals 2 plus or minus 5. 2 plus 5 is 7. 2 minus 5 is negative 3. I'm going back to not writing my answers very well. Letter I. This one looks like it's in vertex form already, so we are going to solve this using square roots. I'm going to add the 48. Then divide by 3. When we divide by 3, we get 16. I'm going to take the square root of both sides, positive and negative. X minus 10 equals positive and negative 4. Add the 10. X equals 10 plus or minus 4. 10 plus 4 is 14. That was a terrible 14. 10 minus 4 is 6. Okay. Here this does equal negative 6 already, so we're pretty primed to complete the square. Alright, so we have x squared minus 18x plus blank equals negative 6 plus blank. Negative 18 divided by 2 is negative 9. Square that, we get positive 81. This is now our perfect square, x minus 9 squared. Negative 6 plus 81 is 75. We're now going to take the square root. X minus 9 equals positive and negative root 75. We can simplify the square root of 75. It's 25 times 3. Square root of 25 is 5. So we have x minus 9 equals positive or negative 5 root 3. We're going to add the 9 over. 9 plus or minus 5 root 3. Alright. X plus 12x equals 3. This one is also pretty ready for completing the square. X squared plus 12x plus blank equals 3 plus blank. 12 divided by 2 is 6, and 6 squared is 36. So we add 36 to each side. Now we can write this as x plus 6 squared. 3 plus 36 is 39. We take the square root of each side. 39 only has two factors, 13 and 3. Neither of them are perfect squares. So we have x plus 6 equals positive and negative root 39. Subtract the 6, x equals negative 6 plus or minus root 39. Last one, our a value is 8. So we could multiply to 16 and add to negative 3, but there actually aren't any factors that do that. So that means that this is quadratic formula. A equals 8, b equals negative 3, c equals 2. Are you ready for the song? X is equal to negative b, so 3, plus or minus the square root of b squared minus 4ac all over 2a. Whew. This goes in the calculator. We get negative 55, so 3 plus or minus the square root of negative 55 over 16. And actually, negative 55 doesn't have any perfect square factors, but we do need to bring the negative out as I. So we get 3 plus or minus I root 55 over 16. Last problem, and then I get to upload this video and put it on Google Classroom. I will also scan this in and post it to Google Classroom as well. An object is thrown upwards from 4 feet above the ground at a speed of 40 feet per second. The height of the object above the ground t seconds after it is thrown can be modeled by the function h of t equals negative 16t squared plus 40t plus 4. Fun fact, negative 16t squared is actually the pull of gravity on our planet. So this is like a real thing that real science people have to do. It is so late, I am saying science people instead of scientists. All right. After how many seconds will the arrow first reach a height of 20 feet? If the height is 20 feet, the height is h of t. So we need to know negative 16t squared plus 40t plus 4 equals 20. Now, I will say, partially because it's late, but also because this is just a lot of work, you can subtract the 20. This would be negative 16, and then you could do quadratic formula. You could technically factor it, or you can do my favorite thing, and that is graph it. Because usually we don't get to solve by graphing. Usually we can only do that if it's a whole number solution. But they said round to the nearest tenth of a second, so we're okay rounding. That means I'm going to subtract the 20, negative 16t squared plus 40t minus 16 equals 0. I'm now going to put this in my calculator and find the zeros. Negative 16x squared plus 40x minus 16. It does say t there if you want t. When I look at my graph, it is real skinny, real quick. It says, when does it first reach a height of 20? So since I subtracted the 20, I want to know the first 0. I don't actually care about the other one. Second calc, I want a 0. And specifically, I want this first 0. So I go until I can see the cursor on the left, cursor on the right. Any guess is fine. 0.50. So after how many seconds will the arrow first reach a height? After 0.5 seconds. Whew. After how many seconds will the arrow hit the ground? It hits the ground when the height is 0. So we have our negative 16t squared plus 40t plus 4, our initial function, equals 0. I'm going to do the same thing because it says round to the nearest thousandth. By the way, nearest thousandth is 3 decimal places. hundredth is 2, tenth is 1. So y equals negative 16x squared plus 40x. Instead of minus 16, I have plus 4. When does it hit the ground? This is not hitting the ground. This first one is not hitting the ground. That's actually before the object was thrown. So I really only want this second 0. Second calc, go to my 0. I have to keep looking for it. Alright, here's my cursor. That's barely to the left. To the right, I have this number. Hard to see. 2.5962912. I'm going to write out the whole thing so that I can just show you, not the whole thing because it's irrational. 5962912. I have my tenths, my hundredths, my thousandths. 2 is not big enough to move that up to a 7. So 2.596 seconds when it hits the ground. We are done with the test review. This is an hour and 45-minute video, but we are now done with the test review. Good luck with your test tomorrow and Friday. Please play whatever parts of this video you need, and most of you will probably not watch this until after you've started the test, so then you can watch it to help you study before you finish the test on Friday. So yeah, I will also upload these actual papers so that you can see all the work. Good luck.